Let's have problem number 4, height of the father and son. The following data pertains to the heights of fathers and their eldest sons in inches. If there is a significant relationship between the two variables, predict the height of the son if the height of the father is 78 inches. At the right corner, you see a two-column table. The first column is for the height of the father, while the second column is for the height of the son. Let's solve first for the correlation coefficient. Let's identify the dependent and independent variables. Our dependent variable is the height of the son, since the height of the son depends upon the height of the father, which is the independent variable. Let's add 3 more columns, x squared, y squared, and xy. Then we add all the entries in each column. You'll get these values. You can pause this video if you want to check and if you want to compute for the previous table. Then, we solve for the correlation coefficient. You see the values below? Substitute it to our equation. Rn is 10, since there are 10 sons and 10 fathers being tested. As we substitute it to our equation, our correlation coefficient R is 0.95. That is very high positive correlation. Now we have our R, that's 0.95, and our N is 10. Let's test if this correlation coefficient is significant or not. We first check. There is no significant relationship between the height of the father and the height of the son. That is the null hypothesis. Our alternative hypothesis states there is a significant relationship between the height of the father and the height of the son. Then we compute for the value of t. Again, our n is 10 and our r is 0.95. We substitute these to the values in our formula. You can pause this video if you want to have some time in solving. Our computed t is 8.61. Let's compare this with the critical value. If our degree of freedom is 8, and using the table for two-tailed, our t is 2.306. Our computed value, 8.61, is greater than our critical value of 2.306. If you'll draw the normal curve, 8.61 is found in the rejection region. Thus, we reject the null hypothesis. We state our decision. We reject the null hypothesis. Thus, there is a significant relationship between the height of the father and the height of the son. Since a significant relationship exists, or we say, since our correlation coefficient R is significant, then we'll proceed to regression analysis. Let's go back to our table. I only have the summation row. Let's solve for the value of A. You could pause this video if you want some more time in solving. The value of our A is 16.55. Now let's solve for the value of B. You could pause this video and solve the problem on your own. The value of a B is 0.78. Again, our A is 16.55, while B is 0.78. We substitute this to the original formula for the regression line equation. That's y prime equals 0.78x plus 16.55. This is the formula or the equation of our regression line. Now let's go back to the problem. The problem asks to predict the height of the son if the height of his father is 78 inches. Remember, the height of the father is the independent variable. That's our x. So we substitute 78 to the value of x. As we solve that, the answer or the predicted height of the sun is 77.39, or we simply say that's 77 inches. This ends our lesson.